So my name is Nataliya Slüsarь, and I work here in St. Petersburg and also in Utrecht at Utrecht Institute of Linguistics. And the title of my talk is Long-Distance Dependencies. So unlike probably many other people who will talk during this seminar, I will focus on linguistic syntactic theory and the predictions syntactic theory makes about different psycholinguistic and neurolinguistic phenomena. And actually, I was choosing among topics because there are a lot of things you can talk about. And I decided to talk about long-distance dependencies because this is central for most syntactic theories. So what do we mean under long-distance dependencies? So if we have this simple English question, what do Englishmen cook? There is a dependency between this element what and the verb to cook. And what do we mean by dependency? We mean that what actually has two roles. It plays two functions. First, it's a question word, so it signals that this is a question. And second, it's the object of cooking. So it stands for what is actually being cooked. And then different modern syntactic theories, they differ with respect to how they represent these types of dependencies. So in generative grammar, they use some zero element. You can call it a gap. So in psycholinguistic studies, it's usually called a gap. And syntacticians either call it a trace or a copy, depending on the type of syntactic theory that you are talking about. And there are many other syntactic theories like HPSG, categorical grammar, dependency grammar, and so on and so forth. And they do not have this zero element after the verb. So they represent this long-distance dependency between what and the verb to cook as direct association between this WH element and the verb. And today I am going to talk about two things. First, syntactic theories postulate these dependencies. Is there, are they psycholinguistically real? And if they do manifest themselves in some psycho-neurolinguistic phenomena, how in particular? And the second question that I'm going to ask is whether we can use experimental evidence to distinguish between these competing syntactic theories. And I'm going to use terms gap and filler. Gap is the place this WH word relates to, and the filler is the WH word, and I'm going to use these terms theory neutral. So I do not want to subscribe to any particular theory in the beginning. So what do we know about these long-distance dependencies from psycholinguistic research? So the first fact that we know for sure is that once we encounter this filler type element, a WH word, we start actively searching for the place it relates to. So if you are in this non-generative perspective, then for the verb. If you are in the generative perspective, then for this gap or the position of the trace or the copy. So how do we know? If we start reading this sentence, my brother wanted to know who, then Ruth will bring. And as soon as we come to bring, we understand that this is a verb, and who can be an object of this verb. So we postulate this dependency. I here show it as a gap, but yeah, I want to remain theory neutral so far. How do we know that this is postulated? Because actually, if instead of this gap, we see another element, us, we slow down. So the complete sentence would then be, for example, my brother wanted to know who Ruth will bring us home to at Christmas. So the actual position of this zero element would be after to and not after the verb. And of course, to show that we slow down, we need some comparison. So you can't measure a slowdown if there is nothing to compare it to. And here is a sentence that it can be compared to. My brother wanted to know if Ruth will bring us home to mom at Christmas. And these facts we know for quite a while, so since the middle of the 80s, so these particular sentences are from Stowe's work, but there are plenty of other studies. And of course, maybe we want to ask whether the first sentence is, generally speaking, more complex because, say, WH questions are more complex than these yes-no questions. And this was also tested. So the complete kind of paradigm of test structures that Stowe used is given here. So it's not only about WH question, but it's actually about postulating the dependency as soon as we see the verb. So the second fact that we know for sure about these long-distance dependencies is that not only they are psycholinguistically real, but also the longer the dependency is, the harder it is to process. So for example, I have two examples in 1 and in 2, and the sentence in 1 is read faster than the sentence in 2, although they contain the very same words. So the only difference between them is that in 1 the dependence is shorter, and in 2 the dependence is longer. So 1 is the detective hope that the lieutenant knew which accomplice the shrewd witness would recognize in the lineup. And the second sentence is the lieutenant knew which accomplice the detective hoped that the shrewd witness would recognize in the lineup. So, and we can see this not only in reading times, but also in many other measures. So this sentence comes from a study by Colin Phillips, Nina Kazanina, and Abada. And they also compared these sentences. They just asked people which sentence is more difficult to process, and this shows up in these offline ratings, that the first sentence is easier than the second sentence. And it also shows up in P600 amplitude, so it co-varies with difficulty. As many of you probably know, P600 is not only an indication of a syntactic mistake and the repair process, but it's also an indication of syntactic complexity, and so here we can see that it co-varies with difficulty, and also here. I'm not going to go into these details because I just want to demonstrate that it shows up in different measures. So the third fact that we know about these long-distance dependencies is that the element gets reactivated. So this filler element gets reactivated as soon as the dependence is established. So it was first and probably most convincingly established in these cross-model priming experiments. So let me briefly introduce the technique for those who are not familiar with that. So a participant listens to a sentence and at the same time performs a lexical decision task, meaning that at particular moments during this sentence, he or she sees on a screen some words or non-words and is asked to respond whether it's a word pressing one button or a non-word, a pseudo-word pressing another button. And for example, when we want to know whether, say, different meanings of a homonym are activated in processing, then we can use this technique. So, for example, on this old-fashioned picture, the guy listens, is listening to a sentence. John saw several spiders, roaches, and bugs. And a bug is an insect, and also this spy device. And if we want to know whether the spy-related meaning is activated despite this context, at the very moment when the word bug sounds, we present, say, a word spy on the screen, and if the participant reacts faster than in the control condition, then we know that both meanings got activated. And this is, in fact, what happens. And so this technique was also used to establish the reactivation effects. So we can look at visible elements first, because this can be easier to do first before we go to these zero elements for invisible dependencies. So if we look at the sentence like, the boxer told the skier that the doctor for the team would blame him or himself for the injury. And then In this case, we do not want to establish any immediacy, so in this experiment by Nicol, the stimuli for lexical decision task were actually shown at the end of the sentence. And if the sentence had himself in it, then reaction times for the words related to the doctor were shorter, and if it had him, reaction times for the words related to the boxer and skier were shorter. So this shows that people actually, they see a pronoun and they establish a reference, they go back to the element, to the antecedent. And so we can see the very same things with long distance dependencies with WH elements. So say that the classical example is which boy did the old man from Osaka meet at the station? And yeah, the verb is meet, and the alleged position of this zero element, a trace or a copy, is right after the verb. And we can see that if we present words like boy before this position, so closer to the actual which boy word, and right after the verb meet, then the boy is recognized faster in the second case, although I mean linearly, it's this position is further away from which boy. And if we compare it to the words like, I don't know, girl, it's the same for the words like girl, so both positions are, there is no difference. What is important here, that so far this does not let us tease different theories apart. So it's both compatible with the theories that postulate the direct dependency between which boy and the verb, and it's compatible with these trace copy theories. So if we want to, then people wanted to see where exactly this reactivation happens. And first they tried to look at the cases where the hypothesized position of the trace is separated from the verb. For example, say take the verb give. It has two arguments and they wanted to look at the second one. In examples like, to which child did the teacher give a long speech about the importance of honesty? So the position of the gap would be after honesty, so long after the verb. And actually various diagnostics indicate that the dependency is formed at the verb and not at the trace position, so it's formed early. And at first it was taken as an indication that these copy trace theories are incorrect. But actually, if you just think about it, it's compatible with both theories. Because in the generative grammar, you also assume that this to which child is an argument of the verb to give. So you expect to which child to be reactivated at the verb and then at the trace position. So actually, to give you some like actual timings from a study of Nicol, 1993, she tried priming at the verb and at the trace position, and in the first position there was the priming effect. And at the second position there was a priming effect too. Although of course, like in this type of the experiment, it's difficult to say whether the thing actually got reactivated twice, or it got reactivated at the verb, and then this activation decreases again to the resting level. And we will come back to that because there are examples where you can't actually distinguish. So then Nicol also showed that the reactivation at the verb does not depend on anything like traces, because say agents get reactivated at the verb, things that generative theory doesn't postulate traces for. Yeah, but as I said, this still doesn't let us tease different theories apart, because arguments could be reactivated twice. Then, if we, I just showed one type of experiment, but actually there were a lot of experiments exploring these active search and reactivation effects. And what we know for sure is that there are diverse measures that all converge on similar generalization. That WH dependency formation occurs at least as soon as an appropriate verb is encountered, and as soon as an appropriate verb is encountered, you try to establish this dependency. And for example, if say this WH word is not a good argument of this verb, right at the verb you get an N400 effect. So yeah, to present different types of studies that were done. So field gap effects studies were done, like the one I showed you in the very beginning, who Ruth will bring us home to at Christmas. So then cross-model priming studies I have already demonstrated. Then also quite a few people did plausibility manipulations in reading studies. And then eye movements in the visual world paradigm. And let me show this one. So in this study by Zussman and Sedivi, they first presented participants with a text. And this particular text in this example is about Jodie eating breakfast, and Jodie is arachnophobic and she sees a spider. And then yeah, instead of screaming or freaking out, she took off her shoe and slammed the spider down, and slammed it down on the top of the spider. She ate the rest of her Fruit Loops in peace. And then you see this picture with some milk, with Jodie eating, with the spider and the shoe. And then the crucial, and then you see you see the questions like or here are the questions. Did Jodie squash the spider with her shoe? This is the control type of question, and the important question is what did Jodie squash the spider with? And actually, you can see that when people hear this sentence, what did Jodie squash? They start looking at the spider. So this shows you in another type of experiment, in another type of experimental paradigm, that the dependency is formed immediately. And then they hear the word the spider with, and then they start looking at the shoe. Yeah. Yet another type of experiments that were done are electrophysiological studies where people, for example, were able to demonstrate that, say, N400 effects appear immediately if you see the verb and you understand that this WH phrase is not an appropriate argument of that verb. And as the slide says, some measures just pinpoint that this long-distance dependency have some processing cost, and some others give more specific information. Yeah, this is the N400, one of the studies. But all this is very interesting, and all this shows, like in real time, how these dependencies are established. But still, none of these experiments allows us to tease different theories apart. So, are there any experimental data that can be used to do this? Yes. So first, there are some experiments on Japanese. And why Japanese is important? Because in Japanese, the hypothesized trace position is before the verb. Because Japanese is verb final, meaning that where, say, in Russian or in English, we would have something like John saw Mary. In Japanese, we would have John, Mary, saw. So the position where the trace is before the verb, so now we can see whether the reactivation will actually happen there. And so another type of experiments. Is experiments where verbs have different argument structure. And these ones I will come back to later. So to explain, to present the Japanese experiments, I will have to present like a couple of facts from Japanese, and I will try to do it in the most easy and comprehensible way. And also I do not have any actual Japanese here, as you can see, because my Japanese pronunciation is absolutely terrible. So this is why I replaced all the words by English words wherever I could. So first, Japanese is verb final, as I already said, and Japanese uses question particles to mark questions. So here is a yes-no question in Japanese, meaning Mary, nominative, book, accusative, read, and then this no is a question particle, and it means what? It means did Mary read the book? And another fact about Japanese is that canonically, normally, Japanese WH elements are in situ. Meaning that if this element, say, denotes an object, it would be in the canonical object position. So here is an example of a question, and it's Mary nominative, what accusative, read, question particle. What did Mary read? So as you can see, in English, this WH element is in the beginning of the sentence. In Japanese, it's where the normal object would be. So then another fact about Japanese is that the position of the question particle indicates the scope of the WH question. So here is an example of a direct WH question. So Tom wa, this wa indicates that Tom is a topic, so it's a topic particle. Then when you see Mary ga, Japanese speakers understand that this is a start of an embedded clause, because tomwa is obviously like in the main clause, and then if you have this another nominative phrase in the another nominative phrase, then it means that an embedded sentence is starting. Then Tom topic, Mary nominative, what accusative, read, and then this if this read has a declarative thing attached to it, a declarative morpheme. And then follows the verb said with a question particle. It's a question, what did Tom say that Mary read? And direct WH question. And you can also have an indirect one if it starts the very same way. Tom topic, Mary nominative, what accusative, read, question particle, and then said. So this means Tom said what Mary read. Is this clear? Is this clear enough? Okay. So as you can see, there is a temporary ambiguity here. So if after this what, you have a verb with a declarative particle, or a verb with a question particle, like the sentence will be interpreted differently. And there were quite a few experiments, so some of them are mentioned at the bottom of the slide, that show that people actually read the verb with a question particle faster. So they prefer, more or less like in English, they prefer to interpret this question word, this WH word, as soon as possible. Because the particle shows the scope of the question. So they want to determine the scope as soon as possible. So they read the verb with the question particle faster. Yeah, so as it says, there is a locality bias. Like in English, it just works differently because the structure is different. So now, although canonically, as I said, these question words in Japanese are in situ, Japanese is a free word order language to a certain extent, like Russian or Finnish, unlike English. And we can, or rather they can, because I can't do that, not being able to speak Japanese. So they can take the WH word out of the sentence and put it in the beginning of this whole sentence. So then the sentence would be something like who dative, Tom topic, Mary nominative. And then after that there will be this assumed trace position or copy position. And then book accusative, gave question particle, said. And the verb final property of Japanese provides us with these temporarily ambiguous structures. So if the sentence starts like who dative, to whom, Tom topic, Mary nominative, book accusative, it can have two endings. Read with the declarative particle and said with the question particle, or read with the question particle and said without any morpheme. So the first structure would mean to whom did Tom say that Mary read the book? And the second structure would mean Tom said who Mary read the book to. So as you can see, in this case, this who dative is part of the main sentence, so it's related to the verb said. And in the second case, it's part of the embedded sentence. So now let's do an experiment. So actually, Aoshima and colleagues did this experiment, trying to compare which of the two continuations would be read faster. And actually, you see that read with a question particle is read faster. So readers slow down if they see a declarative complementizer that is like higher up in the slide, which shows that they want to interpret the WH phrase in the embedded sentence. And if you are a syntactician, it's a little bit strange for you, because this means that Japanese speakers prefer long-distance scrambling. So they prefer the version where the WH word goes out from the embedded sentence and not from the main sentence. But on the other hand, if they prefer this lower version, interpreting the WH word in the embedded sentence, this means that they can determine the scope of the question, the scope of this WH element, as soon as possible. They don't have to wait for the main verb. So, and now, let's do the following. Now, let's do what we did in English. Let's put some dative nominative phrase there and see whether the Japanese people will exhibit this filled gap effect. So we know now that they prefer to interpret the WH word in the embedded sentence. So the verb is not there yet. Will they try to postulate a gap position there? If they will, if they do, they will slow down. If the dependency is established only at the verb, there will be some problems at the verb, but not at this stage here. So is the contrast clear enough, or shall I repeat? Now we know from this previous experiment that I have just demonstrated that people want to interpret the WH element in the embedded sentence. But the verb from the embedded sentence is not there yet. But the trace position is here. So let's fill this trace position with some other element and see if the people slow down. And if they do, it means that the effect, the slowdown effect is before the verb has arrived. And it means that they do postulate a gap here before they actually see the verb. And in fact, they do slow down. So this demonstrates the target sentence and the control sentence, because obviously we can measure whether somebody slows down or not only if we compare this sentence to something. And I showed them schematically because, I mean, even in English these experimental sentences are hard enough to process. In Japanese it would be probably way too hard. So this is why I demonstrated them schematically. So the target sentences, for example, started with a WH word with a dative morpheme. Then comes this topic. Then the nominative phrase, signaling that the embedded clause has started. And then people postulate the gap. And they slow down when they see that actually there is an dative noun phrase following it. And the control sentence was with a nominative WH phrase, and then again it also had a dative DP, a nominative NP, and then a dative noun phrase. Yeah, and so you can see in comparison that in the first case where they try to postulate a gap, they slow down. So generally speaking, this can be taken as an argument for trace copy theories of long distance dependencies, with a small reservation. There are people who think that actually as soon as people start processing the embedded sentence, they postulate a verb in advance. So as we know, we try to build as much structure as we can in advance, and some people would actually argue that people postulate some abstract verb position in advance, and this explains the effects. Actually, I do not think that this is very convincing, but I have to mention that because some people do think that this is the case. But let's go to another area where we can try to distinguish between different theories of long-distance dependencies. So here are two examples from Spanish. And the first example means the elegant critic who visited the museum talked with care. And the second sentence means, again, the elegant critic who visited the museum arrived with care. And if you go to the linguistic theory, not generative linguistic theory, but kind of any linguistic theory that deals with predicate argument dependencies, you will see that these two types of verbs are different. So the verbs like talk, they take an agent argument. So somebody who does something purposefully, intentionally, and controls the situation. And verbs like arrive, fall, and so on, they take what is called a patient argument. So the role, the semantic role of this argument is that something happens to you. So you do not have any control over that. You don't do this purposefully, willingly, and so on and so forth. So, and this is universal. This has nothing to do with, say, generative grammar. This is present in many syntactic theories that, or not only semantic theories also, that deal with predicate argument dependencies. What is specific to generative grammar is that these two sentences in the generative grammar have different predicate argument structure, and actually there is a trace position postulated in the second case, but not in the first case. And in 1997, Beaver and Sons did the following experiment. They tried probe recognition technique. What is probe recognition? You read the sentence and then you get a question whether this or that word was present in the sentence. So it's similar to priming. Obviously, it doesn't demonstrate immediacy. So if you want, for example, to see when something got reactivated, it's not good. But on the other hand, this probe recognition technique, the reaction time differences are larger. It's easier to get statistically significant results. So, and with these two examples, they asked people after the sentence whether the word nice, elegant was in these sentences, and they got a reliable difference between these two types of sentences. So in this particular case, the mean response for the first type of sentence was 1070 milliseconds, and in the first type of sentence it was 950 milliseconds, so 120 milliseconds statistically significant difference. And this is something that you absolutely cannot explain if you just postulate that at the verb you reactivate all the arguments and see what kind of roles they have. To explain something of this sort, you need a theory that has something like traces or copies, and a theory that actually would tell you the positions of these traces or copies for different types of predicates. And actually, unfortunately I won't have time to go into that, because that would require a whole introduction into predicate argument theory. But there is an even more, in my view, an even more striking study done by Luz Kuring, Pim Mak, and Eric Royland, who is, by the way, sitting here. It came out in Cognition in 2012, and actually they not only show different patterns for these two types of verbs that have, say, agent or patient arguments, but they also tease different generative approaches to argument structure apart. And they use a very different type of technique. They use this visual world paradigm technique, tracing where people look on the picture when they're listening to sentences with, say, this type of predicate argument structure, another type of predicate argument structure, another type of predicate argument structure. So I won't go into the details here, so I refer you to the paper. So then yet another very interesting topic related to long-distance dependencies that I wanted to talk about are dependencies without WH words. So if you take, say, generative theory of long-distance dependencies, they postulate these dependencies not only in cases where you have questions, but also, for example, in passives. So if you take a sentence like, the dentist from the new medical center in town was invited by the actress to go to the party, the theory actually says that the dentist originates as an object of the verb invite, and then either, depending on the theory, gets copied higher up in the structure and appears in the beginning of the sentence, or is moved. So this copy movement distinction is important for syntactic theory, but is not important for us now if we are talking about psycho and neurolinguistic data. So here also we have this alleged trace position after invited in the second sentence, and let's see whether we get the same effects as in the sentences with WH words. Why would that be interesting? That would be interesting because there are many theories that treat these two types of structures very, very differently. So in generative grammar they're similar, in many other approaches they're treated very differently. So in this experiment, Osterhout and Sweeney, they tried priming at 3 positions. So first, immediately at the alleged trace position, and this is shown by this x1 in example 2. And they were comparing this passive sentence with an active counterpart. The dentist from the new medical center in town invited the actress to go to the party. And then they also tried priming in this x2 position approximately, which was 500 milliseconds after the verb invited has sounded. And then at another position that is shown by this x3 in example 2, which was 1 second, so 1000 milliseconds after the alleged trace position. And what was interesting that there was no priming right at the trace position, no priming in this second position, 500 milliseconds after the trace position, but there was significant priming effect in this third position, 1 second after the alleged trace position. So what does this mean? So apparently, again, these long distance dependencies, filler gap dependencies, are established, but for some reason they're established slower than with WH words. And actually, in this experiment here, we were also talking about probe recognition after the sentence was already read by participants. But if we could try right after the verb, there would be no difference. Like, people tried that in terms of reaction times. In this respect, this visual world paradigm experiment may be more revealing because you actually can trace this process in real times, seeing where people look at the picture depending on the type of the predicate. So why is this the case that these types of dependencies are slower? Actually, there is no good established theory at the moment. So one can, of course, say that WH elements are kind of more obvious fillers, but this is, this is not what a good theory should say. So at some point, like in the 80s, for example, in generative grammar, WH traces were, like in theoretical terms, very different from the traces of normal noun phrases. But this is not the case anymore. So we could rely on that earlier, we cannot rely on this anymore. So this question still has to be answered. And this, of course, we are not just talking about this one study. It was demonstrated for many different constructions in many different languages that these types of dependencies are slower. Then what can be added to that is that gaps in embedded clauses, like, for example, a gap in this clause, the policeman saw the boy that the crowd at the party accused of the crime, so the alleged trace position would be, or copy position would be after accused. Or actually, in modern theory, you would not necessarily do this in trace copy terms. You can also have an operator there. It really depends on your syntactic theory. But what is important for us now is that, again, a long distance dependency gets established between the boy and something sitting in this position, some invisible element sitting in this position. And this dependency is established as fast as the dependencies with WH words are established. Although here we deal with noun phrases, and there we deal with WH words, and other noun phrase gaps are found slower. And again, in the 80s, the generative grammar had a good explanation to that, because the traces in embedded clauses were similar to WH traces. But the theory has changed. So again, this is a phenomenon that we do not have like a good, well-established explanation for now. Then yet another thing that is interesting to talk about is that many generative grammarians appeal to movement to explain not only WH questions or passives, but also so-called free word order in languages like Russian or Finnish. So, for example, in Russian, in Russian we can say something like she saw him, but we can also say something like, with pronouns it doesn't work that well, but I just want to show this in like on something that shows case in English. So we can also say something like, let me do it with morphemes. Mary accusative, saw John nominative, Mary accusative, John nominative, saw, and so on and so forth. And Finnish is another language that also allows for these word order permutations. And many generative grammarians also appeal to movement to explain this. So one structure is taken to be the canonical word order, and you derive other possible word orders by movement. Not all generative grammarians do that, so some people actually think that different word order permutations are not derived from each other. So this is again an unsolved question. but at least some people, and say I am one of them. So as a syntactician, I work on Russian word order, and I would actually bet on movement. So, and there is also a large and interesting body of research that was trying to trace these types of long-distance dependencies, if they exist. So, and what is interesting about that is that what is often reported as first psycholinguistic studies dealing with syntax were the studies in the middle of the 20th century trying to assess the psycholinguistic reality of transformational grammar. So in transformational grammar, this early version of generative grammar, there was surface structure and deep structure. Surface structure was derived from deep structure by some transformations. And it's not important for us now what these transformations were. It's important that people made the prediction that each transformation would take some time to process. And so let's detect this time. And the final outcome of these experiments was that time spent on many operations turned out to be absolutely impossible to detect experimentally, and that it was immensely difficult to exclude other factors. These experiments, first there was some success, and then when people went deeper into these problems, these experiments failed miserably, and that was a reason for many formal syntacticians to become disinterested in any sort of psycholinguistic or neurolinguistic experiments, and the reason for many people doing experimental research on language to become skeptical about syntactic theories. So actually, if you look at generative grammar, like grammatically, like syntactically informed studies of experimental studies, psycholinguistic and neurolinguistic studies, became commonplace rather recently. So although this idea that any transformation should be detectable psycholinguistically, it was discarded more or less in the 60s, if not earlier. This approach survived, funnily enough, in the experiment studying how different word orders are processed. So the idea is quite simple. Take whatever is the neutral word order in a given language, take whatever is non-neutral word order, and see how much time is spent on these alleged additional movements. Non-neutral is often called scrambled in generative theory. So, and a lot of people tried that on different languages and found out that neutral word orders are indeed processed faster in many languages. That was demonstrated on Finnish, on Japanese, on several Slavic languages, and so on and so forth. But actually, if you speak a language like Finnish or Russian, and if you just take some time to think about it, you will see that neutral word order is felicitous in isolation. So you can say something like John nominative, so Mary accusative. Just out of the blue, it would be okay. But to say something like Mary accusative, so John nominative, you need to have some specific context. So, for example, one of these contexts would be, so Mary was mentioned already, and you know that somebody saw Mary, but you do not know who. Then this word order would be felicitous. If you have this, if the object is already known and the subject is new. And there are other contexts too, but this is a very good context that kind of shows what I'm talking about. And actually, all these people who were testing the differences between neutral and non-neutral word orders, they were presenting these sentences in isolation. So, to give an example, they were giving people sentences like, I don't know, to give a very simple example, John nominative, so Mary accusative, or Mary accusative, so John nominative, were like comparing what the difference was, and were saying that the fact that the second type of structure takes you more time to process is explained by the fact that you undo these additional movements that are required to build this structure according to certain syntactic theories. But several works, one of them is by Elsie Kaiser, who works on Finnish, and John Truswell, and another work is my own paper in the Journal of Psycholinguistic Research, a 2011 paper. They looked at I looked at Russian and they looked at Finnish, and the kind of the starting idea of both papers was that the neutral word order is felicitous in isolation, but scrambled orders are not, and maybe this is the source of this additional slowdown. And Kaiser and Truswell, they looked at Finnish subject-verb-object versus object-verb-subject structures. And they were actually able to show that when you manipulate the context, so when, say, in the first case the subject is given, and in the second case when the object is given, so when both sentences are appropriate, then the difference is really reduced. And they also did a very, there were two types of experiments in this paper. So the first experiment was this reading time experiment, and the second experiment was with pictures, an eye tracking study. So they were able to show that if you give people this object-verb-subject sentence, and the object was given, and these people look at the picture, and at the picture there are some characters that were introduced before, and some characters that haven't been mentioned in the previous context. That upon hearing this given object, people actually start looking at these new characters on the picture. So actually they expect the subject to be new information. So this can be shown online in their looking patterns. What I did on Russian, I was looking at more complex structures. So I was looking at Russian sentences with a subject, a verb, an indirect object, and a direct object. And so the canonical word order in Russian is subject, verb, indirect object, direct object. And I was also looking at two non-canonical structures. So the first just had a direct object as a topic in the beginning of the sentence, direct object, subject, verb, indirect object. And the second type of structure was two objects in the beginning, then the verb and the subject. And so why would this be interesting? This would be interesting because if you believe that any word order transformation requires some additional time to be undone, to be processed, then you would expect that this third structure would take more time than the second one, and the second one would take more time than the canonical first structure. So, and I presented these sentences in one sentence appropriate or inappropriate contexts. And so the appropriate context established two first arguments as given. So in the first case, the subject and the indirect object. In the second case, the direct object and the subject. And in the third case, the two objects. I also had inappropriate context. contexts that presupposed these new given or given new given orders. So either the first and the last argument was given and the second one was new, or the first argument was new and the second and third one were given. And this was a reading time study. And what I was able to show was that when presented in appropriate context, these sentences take very same time to be processed. So there was not only no statistically significant difference, but also more or less no visible difference between these sentences. And if you put them in inappropriate contexts of the same type, they all take significantly longer, and again there is no difference between the three word orders. So I guess that the less pronounced context effect evidenced in previous studies. Yeah, it says previous studies, but actually people didn't look at these structures and context so much, so more or less it's Kaiser and Roosevelt study. So it might be, in my view, it might be due to the use of shorter target sentences and less extensive context in Kaiser and Roosevelt's case. So, and another thing that I was able to show, because I had longer structures, was that the slowdown starts at the first contextually inappropriate constituent. So the information about context requirements is taken into account immediately, and this correlates with what Kaiser and Roosevelt were able to show in their picture study, in their eye tracking study. So they also showed that if you see a sentence that starts with a given object, you immediately expect a new subject, the subject that wasn't mentioned before. But again, what I was able to show that although the slowdown starts immediately, it develops faster on the elements occupying their canonical position, so on pre-verbal subjects and post-verbal indirect objects, then on pre-verbal objects that occupy a non-canonical position or are scrambled. So here you can see some evidence for, probably for syntactic movement, but this evidence is not in. It's different than it was initially assumed. So initially people thought that if you have this additional movement operation, the sentence will take longer to process. So I was able to discover a quite different effect. So the timing is the same. This movement operation doesn't take any detectable time, but it shows up, manifests itself differently. So, and I also did a second experiment where these findings were replicated for other orders. Yeah, so I probably already said something about whether these type of data tell you something about movement in these structures. So I think that this finding can be taken as an indication that even in these cases there is movement. And then the next question is it surprising in any sense that we can't detect the actual time that the processing of this additional operation requires? I guess if you are a speaker of Russian or Finnish, if you think a little bit, that would be an easy question to answer. Both Russian and Finnish allow massive word order permutations. If these word order permutations would each take some noticeable amount of time, a lot of Russian and Finnish sentences would be simply unprocessable. This is why I do not think that this is in any way surprising that the cost of these additional operations cannot be detected experimentally. And we can also say that the cost of many other syntactic operations on which different syntactic theories absolutely converge also cannot be detected experimentally, because yeah, sentences have a rather complex syntactic structure. If any kind of tiny bit of it would require massive effort, we would not be able to speak our human languages. So, and actually I was talking faster than I initially thought I would. So we will probably have longer question period. And since I went over many things rather fast, I now invite you to ask any questions or to discuss like all these things in more detail, whatever you are interested in.
I have a little question. Could you go to the very first slides where you talked about this work of Nicol of 1988 with Bolser and the doctor, him and himself?
Just a second. Yeah.
So Bolser and reaction times for Bolser and Ski are shorter. Does it mean that both are, activated at the same time, or just one of them?
You mean that the words boxer and skier are shorter than the word doctor?
Yeah.
But of course they were not comparing boxer and skier.
Reaction times are shorter for boxer and skier if it's him, not himself, yeah?
No, they were of course comparing boxer to boxer in a control condition, where there is nothing about boxers, and skier to the skier in a control condition where nothing can be related to skiers, and the same like for all cases. So what I wanted to say here is that in the first case, the reaction times for the words related to doctor are shorter than in the control condition, and the reaction times for words like related to boxers and skiers are the same as in the control condition. And the situation is vice versa if the sentence has him in it. So does it?
Does it mean that both in boxer cloud and skier cloud are activated on him?
Actually, this is a very good question, because what I think actually should happen here is that some speakers should choose the boxer interpretation, and some speakers should choose the skier interpretation.
Right. In that case, in some speakers you wouldn't have this shortage of reaction times.
Actually, like, to be sincere, there are some doubts associated with the cross-modal priming technique in general. And these doubts go approximately like this. So when you ask about something related to the boxer or the skier, you may hint. You kind of, people can retract and kind of reinterpret him and think that now the question is about the boxer, so probably him was the boxer. So these are, I'm not sure whether these effects actually do take place, but at least some people express some concerns about that. So to be kind of absolutely sincere, I should have probably told that. Yep. So,
let's have a break and
yeah,
just
Alexander.
If I understand correctly, in Finnish, when we do not have keyboard, or in this sense that it is completely free. So when they are changing the parts in the sentence, we still are dealing with topicality. So it's not completely free.
Yeah.
So if it is not canonical, then we have to add something.
Yeah, exactly. So more or less, this is what this Kaiser and Roosevelt study shows for Finnish, and this is what my study shows for Russian. That actually people who were who were dealing with this free word order initially were dealing with it as if it's completely kind of as if it has no interpretation effects. So at some point when Saito introduced the notion of scrambling into the syntactic theory, he, although for different reasons, not because he did not understand the semantic impact, he called scrambling semantically vacuous movement. Meaning, yeah, he meant a different thing, but some people took it quite literally. No difference in meaning whatsoever. And actually, if you go deep into semantics, there is this interesting debate whether scrambling, actually, free word order, let's stay theory neutral, whether free word order is associated with truth conditional differences. And this is really important for semanticists, but for us here now, it's important that it's definitely associated with some differences. And these differences are in what is called information structure, about which word is presented as, say, salient, non-salient, given or new, topical or part of focus, and so on and so forth. And both Kaiser and Trusswell study, I can't come back to that. So both Kaiser and Trusswell study and my study shows that this is what matters when you process these things. And not the syntactic operations that possibly underlie these different word orders. So in this respect, the study kind of confirmed, both studies confirmed that this is not free variation. And if you try to investigate it as free variation, you get results that are hard to interpret. Yeah, Eric?
Yeah, one observation. You mentioned that in order to explain the differences between the fact that if you have a WH word, the trace, well, it goes pretty fast, and that in the case of passives, it takes more time. There is a delay. You say, well, there's no good reason for it. Perhaps, I should point out that there's one additional factor in the case of passives. Namely, in the case of passives, you have, say, the standard verb, and you have to carry out a lexical operation. So there is an additional operation that takes place, which is independent of the actual movement.
Yeah, that's true. So in this respect, the theory is developed. So if we say apply this theory to this fact, yeah, this is, by the way, a good explanation for the difference. Because if you take syntactic theory, in the syntactic theory, in case of passives, say people like generative syntacticians and some other people postulate that some operations are done to the verb. And also there is this long distance dependency. So it may be the case that because of these operations done to the verb, it takes more time. But actually, what I wanted to say, it's not that it's unexplainable, rather that there is no well-established explanation that everybody would accept by now.
And essentially, it's a similar approach we have in this in our papers of Corey and Mark, in order to explain the difference between, say, agentive verbs and the fallback verbs.
Yeah.
Yeah, there you have additional operations in the lexicon that contributes to the slowdown. That was very
Can
you comment?
Yeah.
But to begin, I need a whiteboard. I really like the idea you expressed that pragmatic strategies can influence, and they do influence syntactic processing. And I cannot help sharing some new data from our lab with you about that. So it would, yeah. Who did the boy kiss? Right? And from visual world paradigm experiments, we all know that healthy participants look at the girl, if there is a girl on the slide. So, girl, they look at the girl. In English. And English is very poor regarding syntactic structures you can study. So what we did in Russian, we tested the same sentences, the same structures. This is who, accusative, who boy nominative, kissed, right? And here's the girl comes as in English, just exactly as in English. And then we asked, okay, it might be because there is this gap can be filled with a girl, but it might be just a pragmatic strategy to process the sentence. So this is WH question. So I expect, and this is a visual world paradigm. Usually people are expected to answer the question in it, right? So this is who, and then the boy comes. Okay, here I realize, so the question, and then kissed. The question is about another person, another participant, and this is the girl, of course. This is why I look at the girl here. And we tested it using another quite standard Russian structures. This is who nominative. Girl accusative. Kissed. Okay, if you believe that scrambling is a kind of movement, then there should be girl here, right?
A boy rather. Now it's a boy.
Кто девочку поцеловал?
You mean,
girl.
the girl.
Girl
Okay.
came here, scrambled from
Mm-hmm.
here to here. So the girl should be here. But no way the boy. Why the boy should be there, right? Only if you believe in pragmatic strategy to process the sentence, you would expect the boy here, because you saw who here, and then the girl comes, and then some kiss. Okay, this is about the boy. This is why I will look at the boy here, not at the scrambled girl. And this is exactly what we got in healthy participants and in two groups of aphasic speakers. It explains why aphasic patients in the study of Dick and Thompson looked at the girl here as healthy participants did. Because usually aphasic patients do not have pragmatic difficulties. They perform as healthy controls. So contrasting those two sentences, two conditions, we show, this is a very fresh piece of data, we showed that it is pragmatic strategy to process the sentence, not the filling the gap. That's it.
Thanks a lot. So I think that,
But there is also a gap from who, which must be postulated somewhere.
No, this is the subject, this is nominative.
Yeah, the gap from who in Russian would be somewhere around here in the spec of the little VP, if you want the generative perspective. But at least I think what this shows for sure is that there are lots of complications to all these techniques, because I think that it absolutely shows that the fact that we look at the girl does not necessarily show that there is a trace or copy there. But what I believe I was able to show, because I was giving data from lots of different techniques, and as you could see, some of these techniques had nothing to do with this plausibility or pragmatic strategies. Say this Spanish study with the elegant critic. So the difference was exclusively in the semantic role of the two arguments. So what I think I hope that I was able to show that there is some reasonable evidence for this invisible traces or copies. But what these data, I think, convincingly shows is that it's very difficult to interpret experimental data and to exclude other possible factors. As in this Kaiser and Truswell study, where they were able to show that the delay caused by non-canonical structures was not actually due to syntax. It was also due to other information structure related effects. So yeah, thanks a lot. Yeah, so we shall probably stop here, and then if anybody else has any other questions, I will be happy to answer afterwards.